Let's see another data structure today. That's a queue and tree. So the new problem will be based on the queue data structure and tree and the breadth for search. So let's see the problem. So this is a medium level problem. It's a binary tree level order traversal. So it's a level order traversal. It's each level. So like if you see the first level 3 and second level 9, 20, third level 15, 7. So we have to write a code in such a way that like it's a traverse each row and return that data. So if you see here, this is the tree structure, and if you see the output, the first row there is a 3, and in second row 9, 20, and third row 15, 7. So from this data structure we can use queue. So in a queue we can store the data. So we know the property of the queue. This is a first in first out. So what we do, we traverse this tree, and then we store this in a queue, and from the queue we can get the data out and we can return the result. So let's understand how this algorithm works, and then after that we can jump on the code. So in this scenario, what we are going to do is, first we'll create the queue data structure, and in the queue data structure we can add this item. Like let's say I added the 3 on the queue. So yeah, so this is the queue here, and in a queue I added 3, and then we have a loop, the first loop, and in this loop we can check whether queue size greater than 0. So we know we already added a item in a queue, so definitely its size is greater than 0. We have another loop inside, and what we do, we can create another variable like before the loop, and let's say I can say queue size, and we know the queue size is 1 now. So for now queue size 1, and here this loop based on loop queue size greater than 0. So we know that queue size is greater than 0. So there is an outer loop and there is one inner loop. So inner loop is running on the queue size, and the queue size is 1. So in this case what we do, we'll take the one item from queue. So we know you can get the output or remove the item from the queue, from the front, and we have the only one item anyway. We'll get this item 3 here. That's item gone from the queue, and as soon as we get one item out, we can decrement the queue size. So now queue size now becomes 1 or 0. So from 1 it becomes 0. Okay, so but anyway, when it is inside this loop, even though it's a 0, we decremented that and it's a 0, and we are inside this loop, then we'll also check if this item has left value or right value. If it has left value and the right value, then we can add that item in a queue. So we'll add that item in a queue, like we can add 9 and 20, and then we know in the first row it's a 3, so we can add the 3 in a result, and queue size is 0. So okay, so we added the item, and since queue size is 0, we'll come out of this loop, and then again we'll get stuck in the outer loop. And we know if you in an outer loop, if you check the queue size is 2. So again we come inside, and for the 9 and 20 we'll take one item. Like we'll take in inner loop, we'll take one item 9, and for the 9 we'll check if there is a left or right. So there is no left and right. Okay, we'll decrement it. Previously it was a size 2, and we decremented this because we are inside this loop, inside the inner loop. Then we process 9. Then we since we are inside the inner loop, we'll process another item 20, and we'll decrement the loop, and this time the loop will become 0 because we process these two items. And while processing this 20, we can add 15 and 17 here. So in the 15 and 17, we know we already removed the 920 from the queue, so we can remove from here. So there are item 15 and 17, and then when we process the item 2, then this queue size, the queue size will be 0, and in that case we can add this row in a result. So this is the algorithm where we are utilizing this queue, and for queue data structure, and we are using two for loops. So this is very useful. This algorithm is very useful because we can solve many problems with the tree like row level traversal in a tree. So let's see the code and try to understand this code in a better way. Okay, so first thing is we can check whether its root is nil. So if it is if root is nil, then return nil, and then we can add this item. First let's create the queue. So it's a queue, and let's import container list, and then we can use the list.new. So this queue is created, and first thing, add this root in a first item. First item, we can add this in a queue. So queue dot pushback root. Okay, that's good. Now we can have one outer loop where we can check queue size. It's a queue length not equal to 0. So we know we added one item, so definitely it's not 0. Okay, we can have another loop, but before having inner loop, we can define a variable queue length, and then we can store the length of the queue. So queue dot length, and then here we can check for queue length not equal to 0. Yeah, this is also not equal to 0 because we have one item, and then remove the item from the queue inside the inner loop. So queue dot remove queue dot front. That's a element, and it's a node here. So node element. So we'll see it's a tree node. So we got a node now. We can since we remove the item, we can decrement this queue length. So queue length minus minus, and we can check here if queue length equal to 0. So queue length equal to 0, that means on that row we processed each item. So in that case we can add the row in a result. So for that we can create the two variables, one for the result. So let's see what we are returning. So it's a array of array, so we can create that variable. Let's say it's a result int, and we can return the result here. We can create another variable here for the row, to store the data in each label. We can create a variable row. It's a var int, and as soon as we get one item out from the queue, we can add that item in a row. So row equal to append row, and we can add the node. Let's see what is that. Okay, VL, so P uppercase. Okay, so that's good. And here, and whenever like we see the queue lane equal to 0 in inner loop, then in that case we can add this row to result. So it's append and row. So that's all the code, I think. Yeah. So yeah, one more thing, like we added the result, but if it has the left item and the right item, add that in a queue. So let's check that also. So I can check if queue dot, it's a left variable is left, queue dot left is not equal to nil, then in that case we can add this item in a queue. So queue dot pushback queue dot left. In the similar way we can do for the right item. So I can say queue dot right not equal to nil, then queue dot right. Okay, let's try to run this code. Tree node undefined node. Okay, so we need this. Okay, we have to give this colon. Let's try to run again. Queue left, where is the queue left undefined? Or not, it should not be the queue left, but it should be node left. Yeah, node left. And then here also node left and then node right. Tree node. Okay, so tree node, that's a pointer, so we can have the pointer here. Okay, accepted. Let's yeah, we can also, if you want, we can also print this data in a row level and see what is the output in a row level. So in an inner loop, as soon as inner loop is done, or we can say like when the queue lane is equal to 0, we are adding row in a result. If you want to print this result, you can print here row equal to row, and let's run this and see the output. Yeah, so that's output here. Row equal to 3 here, row 9 to 20, 9 20 and 15 7. Okay, so that's good. Let's submit this. Yeah, that's good. So that's a correct answer. Let's see Java solution. Okay, so for the Java solution, it's the same logic, whatever we discussed for Golang. So it's a root equal to null, then return empty list. And then for the result, we have the variable here, and we have created the queue, and we added the root item in a queue, and we have the two loop, outer loop and inner loop. And this is a variable. There is a variable for row. There is a variable for queue size, and inner loop is running on this queue lane variable. We got one item out from the queue, and then queue lane minus minus. We added node value in a row, and when q lane equal to 0, then in this case we can add that row in a result. If left not equal to null, then we can add in a queue. If the node right is not equal to null, then we can add right item in a queue and return the result. So it's the same logic where we utilize this tree data structure, we utilize the queue, and this is the breadth first search. So it's a like breadth search, not like going the depth, but it's a breadth wise. So just row level. Yeah, so that's all for today. Thank you.